Hey there, Mr. Holcomb here with another lesson in pre-algebra. This is a continuation of exponents, and this is session 4 from the Student Companion booklets. Okay, so let's take a look. Applying exponent properties for positive integer exponents, complete the examples below, then solve 1 through 10. So if I look at the example, it says write this expression 6 squared times 24 to the ninth divided by 4 to the ninth as a single power. So look at how you could combine powers with the same exponents. Okay, so we have 24 to the ninth and 4 to the ninth. So we break those away from 6 squared. And since 6 squared is in the numerator, think of it as over 1, and that can just be an integer 6 squared. And then we take the 24 and the 4, the two bases with the same exponent, and put them inside their own parentheses. And then we can divide the bases. 24 divided by 4 is 6. What a cool trick to make the number smaller quickly. So then we get 6 squared times 6 to the ninth, and that is the product rule. So when you multiply, you add the exponent. So it's 6 to the 2 plus 9, and that would be 6 to the 11th power. Okay, so that's one way of doing it. And so here's the apply it. So now it's your turn. So pause the video, see if you can do this. This is a substitution problem. Okay, hopefully you tried this on your own already. When it says evaluate, it wants the value of this not left in exponent form, but completed. First thing I'm going to do is substitute 4 in for this n right there. And then I divide by, and then in parentheses is 9 to the n, but n is 4, so I'm going to change that to 9 to the 4 times 2 to the 5th power. Close the parentheses. Okay. So how am I going to do this? I am going to expand. So 18 to the 4th power means 18 times 18 4 times. Okay, so that's what this is. 18 to the 4th power over, and we have 4 and 2, or 9 and 2, which is 18. 9 times 2 is 18, so 9 to the 4th power would be 9 times 9 times 9 times 9, and 2 to the 5th is 2 times 2 times 2 times 2 times 2. So 1, 2, 3, 4, 5 2s, 1, 2, 3, 4 9s. Okay, so 9 times 2 is 18. So 18 divided by 18 is 1. So if I cancel out a 9 and a 2, I can cancel out an 18. 9 and a 2, 18. 9 and a 2, 18. 9 and a 2, 18. Well, I'm left with 1 in the numerator and 2 in the denominator. So my answer is 1/2. Okay. Number 2, rewrite 5 to the 7 times -3 to the 4th power squared all over 5 to the 6 as a product of two powers. Okay, so there we have it. So I'm going to get my highlighter, and I'm going to point out to you that this exponent here will get distributed to this exponent here, this exponent here, and this exponent here. So the 5 to the 7 times 2 is 5 to the 14 times -3 to the 4 times 2, which is 8, all over 5 to the 6. Okay, in this situation, we have, and I'm going to highlight it, we have 5 to the 14 in the numerator and 5 to the 6th in the denominator. So I can rewrite those as a separate value. So that's going to be 5 to the 14 over 5 to the 6. And then I'm going to multiply that by -3 to the 8th power. So I pulled this out of the fraction and made it as an integer. Okay. And so now all I have to do is my subtraction rule, right? When you divide, you subtract. So 5, 14 minus 6 is 8 times -3 to the 8. So product of two powers, there's two powers. We are done. 5 to the 8th times negative 3 to the 8th power. Number 4. Which expressions are equivalent to 8 cubed 10 to the 6th? So if I distribute this, that is going to equal 8 to the 3, because this is a 1, and 3 times 1 is 3, and 3 times 3 is 9, so this is going to become 10 to the 9th power. Well, that's not matching the 6, so that is not an answer. B, I'm going to rearrange this. I'm going to put 8 to the 5th over 8 squared, and I'm going to multiply it by a separate fraction. You can split up fractions during multiplication, and this is going to be 10 to the 15 over 10 to the 9. 8 to the 5 minus 2 is 8 to the 3, times 10 to the 15 minus 9 is 10 to the 6th. Okay, so we have 8 cubed 10 to the 6th, so B reduced to this value right here. Okay, the next one. If I distribute this 6, that's going to become 8 to the 6th power over 8 squared. Okay, the 8 squared is not in parentheses, so that just comes over. And then I'm going to pull this 10 out in the same step and just put it out here. And 6 times 1 is 6. And 6 minus 2 is a base of 8. So the 6 minus 2 is 8 to the 4th times 10 to the 6th. Okay, so 8 to the 4, 10 to the 6. This is 8 to the 3, 10 to the 6. So C is not a solution. Now I have 8 times 10 to the 4th and 8 times 10 squared. So I'm going to rewrite the 8s. 8 times 8 is 8 squared. Times 10 to the 4th times 10 squared. Oh, I'm sorry. That's supposed to be a 2. My fault. Let me start over. I made a mistake. Okay. But I'm always looking back and making sure. Okay, so I forgot this step here. When I got to it, I realized I'd forgotten it. So this 8 is going to come over here. It's 8 to the 1. And this 8 is going to be 8 to the 1 times 2, or 8 squared, times 10 to the 4 times 10 to the 1 times 2, or 10 squared. Well, 8 to the 1 times 8 squared is 8 to the 1 plus 2, or 8 cubed, times, bases are the same, multiplying, you add exponents. 4 plus 2 is 6. 8 to the 3, 10 to the 6. D is a solution. Okay, and then finally the last one. This 3 is going to get distributed here, here, and here. So it's going to be 8 to the 3rd power times 10 to the 15th power, right? 5 times 3, all over 10 to the 3rd power. Well, this can get rewritten as 8 cubed times 10 to the 15 minus 3 is 10 to the 12th. And that's not 10 to the 6, so this is not an answer. Oh, wait, hang on. Time out. Time out. Hopefully you catch these things when I'm doing it. If you're following along closely instead of just copying what I do. I didn't multiply the 3 and the 3. That should be 10 to the 9. Then 15 minus 9 is not 12. 15 minus 9 is definitely 6. And now it does match. So E is also an answer. Okay. Number 5. Tell whether n equals 4 makes the equation true. So if I put this in, it would be 7 to the 4 squared. And 7 to the 4 squared is 7 to the 4 times 2, which is 8. And this is 7 to the 8. So yes, it does. Okay, so now I'm going to put 4 in here. So this is going to be negative 5 cubed times negative 5 to the 4th, which would give us negative 5 to the 3 plus 4, right? And that's negative 5 to the 7, but that's not 12, so it's no. Okay, so if I put n here as 4, 19 to the 4th divided by 19 to the 1 is 19 to the 4 minus 1, which equals 19 to the 3rd. And if I make n 4, that is not 3, so it's no. In this one here, Don't forget, you have to distribute it to the number as well as the variable. So this is going to equal, actually, what I could do is take 3 times n, which n is 4, and just make this 12 squared, and that does equal 144, so that's a yes. Okay, so this one here, I just want to distribute this to, and that's going to be a negative 2 squared. This is going to become positive, and 2 squared is 4, and 5 squared is 25, and then if I put n in for n, 4 in for n, then this is going to be true, so that is also a yes. Number 6, explain why the number negative 99 to the n times negative 99 to the n is positive. Okay, so what they're basically saying is when you have a base that is negative, because we have a negative 99, and you take an exponent to an even power, that's how you get a positive. So what they're telling us is no matter what we plug in for n, we're going to get an even every time. So let's check that. Negative 99, pick a negative number. How about negative 2 times negative 99 to the negative 2, right? So a negative 2 plus a negative 2 is negative 99 to a power of negative 4. All right, and we have a rule. Think of that as over 1. And when we have a negative exponent, you take the inverse, you flip the fraction. So it's going to be 1 over negative 99, and then the exponent becomes positive. So now that this is a negative fraction, and this is a even exponent, that will become a positive. And then if I choose a negative 99, and I take, actually, I probably shouldn't have used a negative there, but that's okay. How about I choose an odd? That's what I meant to do. Negative 99 times negative 99. And if n is 3, then that would equal negative 99 to the 3 plus 3, which is negative 99 to the 6th. So what's really happening here is we're taking an odd number and adding the same odd number to it, you're going to get an even number every single time. So that's going to be even. And then when I choose a positive even number like 4 and multiply it by negative 99 to another 4, well, that's negative 99 to a 4 plus 4, right? And that's going to give me negative 99 to a 8th power. So regardless of odd or even as our exponent, we're always going to get an even exponent when adding that. And that is why this will always be positive. Okay, hopefully I didn't confuse you with that negative exponent because we haven't done that yet. 7, what is the value of the expression 5 to the 18 times 5 to the 6 over 5 to the 10 squared? So first thing I'm going to do is just rewrite it because it's written kind of small. 5 to the 18 times 5 to the 6 over 5 to the 10, oops, not 510, 5 to the power of 10 squared. Well, the top is our product rule, which says to add exponents when the base is the same, and 18 plus 6 is 24. So the numerator has been simplified. The denominator is the power rule. So up here we added, but down here we're going to multiply because it's a power of powers. And that's going to be 5 to the 10 times 2, or 5 to the 20. And now we have division. So we're going to take 5 to the 24 minus 20. So that's going to become 5 to the 4th power. And it said, what is the value? So that's going to equal, well, 5 times 5 is 25, times 5 is 125, times 5 is 625. Okay. Okay. Session 4, refine. Paulo uses clay to make the cube shown. It is 1 ounce of clay. That's how much it weighs. Its dimensions are, since it's a cube, Okay, here's the key here. So there's no assumptions. Whenever they tell us something is, the height is 2.75, the base is 2.75, and the thickness is 2.75. All three measures are 2.75 centimeters in order for that to be a cube. Okay. If one side were longer than the other, then it would be a rectangular prism, is what that would be called, not a cube. All right, so his little sister Lupe wants him to make her a larger cube with an edge length that is twice as long. How many ounces of clay does he need to do that? Well, if we double 2.75, that's multiplying by 2. That would be 5.5 centimeters. So we're going up to 5.5 centimeters. Okay. So if we are doubling the length, okay, so the key to this, there's a shortcut. Twice as long is the key. So if we double the length, that means that our base is 2. And since it's a cube, then we're going to multiply by 8. So instead of being 1 ounce of clay, it's going to be 8 ounces of clay to make a cube twice as long. Okay, so to verify this, okay, remember our values. We went from 2.75 to 5.5 by doubling each side. So I double checked this. So if I took 2.75, the lengths of the sides cubed, that'd be 20.796875 cubic. What were they? Cubic centimeters. Okay. And then if I double the length, then I get 166.375 cubic centimeters. So something with that size. And then I took the original weight, which was 20.796875, or the original volume, I should say. And I multiplied it by the answer I got, which was 8. It came out to be the same as cubing the doubled length. So I just was verifying that this is true. And so therefore the shortcut does work. The answer is 8 ounces of clay. Okay, number 9. The expression 9 cubed times 9 to the power of 5, written as a repeated multiplication, has blank factors of 9. Okay, well, 9 cubed times 9 to the 1 is 9 to the 4th, all to the 5th, and we multiply, so it has 20 factors of 9. Okay, just asking what the exponent was. So number 10, math journal, rewrite each expression as a single power. So we don't have to solve this. We just want to get it down to one exponent. Use repeated factors to explain your answer. So this is going to equal 38 to the 5 times 2, because it's the power rule, which equals 38 to the 10th power. And then if we check it using repeated factors, okay, well, this would be 38 times 38 times 38 times 38 times 38. 1, 2, 3, 4, 5 in parentheses. And then squaring that means to do another parentheses of the same size. 1, 2, 3, 4. Whoops, I said 4 instead of writing 8. I said 4, wanting to write 8, but wrote 4. 1, 2, 3, 4, and one more, 38. So 5 twice is 10. Okay, part B. Okay, this was the quotient rule. Same base, subtract the exponents. 6 minus 3 is 3. So that's going to be 20 times 20 times 20. Okay, but this is 20 to the 6. 1, 2, 3, 4, 5, 6 divided by 20 3 times. So this and this cancel. This 20 divided by 20 is 1. 20 divided by 20 is 1. And we're left with 3 20s. Okay, so that brings us to the end of session 4. Thanks for watching. Have a great day.